Now, this wasn't asked on the document for today, but we're going to do this just to extend this a little bit more and to kind of reinforce the meaning of a frequency distribution. We're going to calculate the average deviation for this frequency distribution. Now, later on, you'll calculate the standard deviation, but it's much easier to understand the standard deviation if you know how to calculate an average deviation. It's a fairly simple adaptation. Okay, well, we found the mean, $764. We want to find the mean deviation. Well, it makes sense then. We could do it, again, by listing all 17 results. The list is short enough that that would actually be feasible. It would kind of be a waste of time, but it would be feasible. And we could say, okay, well, 700 deviates from the mean by $64, okay? And 800 deviates from the mean by, what, $36, right? 800 minus 764 is 36. And 1,000 by 236, and that's a very easy calculation. So what do we have? We're going to have 10 deviations of $64, 5 deviations of $36, and 2 deviations of $236. Well, it's easier to do that if we just write it out and remember what the frequency distribution means. It's easier to do it in terms of the frequency distribution. We know we have 700 10 times. We know the deviation of 700 from the mean is 64. So we multiply 10 times our $64 to get $640. That's the total of the deviation that you get from the 10 700s. Then the 800, we know, deviates by 36, and there are 5 of those. 5 times 36 is 180. So there are total deviation of those who make a salary of 800 per pay period have $180 total deviation. And for the 1,000, there are 2 of them, and the deviation is $236. 2 times $236 is $472. We add those up, we get $1,292. That's our total deviation. So that our average deviation is our total deviation, $1,292, divided by the number of salaries, the number of times, the number of instances for which we get values. And that, as we see, is 17. We divide that, and I said, I'd call that approximately $75. It's actually about $76. So, so we'll say that's approximately equal to 75, but it's actually more like 76. So we see on the average how much salaries deviate from the mean. Now, in an organization, you're going to have people who are probably worth $1,000 when you have people who are worth $700. That's not an atypical. Matter of fact, that's a fairly small deviation. So that the average deviation is only about $75 per pay period. In a typical organization, I think you'd probably have a wider variation. So you might think of how you would calculate that and about what that means. And I'll just mention, if we want to do a standard deviation, what do we do? Well, if you remember what I said about standard deviation, and it's not absolutely necessary that you do, because we'll say it again probably in the next class. But the standard deviation, you're going to square the deviations. Going to give you some fairly big numbers here. That's going to be around 50,000. But we square the deviations, and again, we multiply by how many there are. So we get the numbers for the total square deviation for the $700, for the $800, for the $1,000. So we're going to get a column very much like this, but with much bigger numbers. And then we're going to we're going to add those up and average them. We're going to get an average squared deviation, and then to reconcile things, we're going to take the square root of that average. And you can understand how we could set that up in a table very easily just by adding 2 more columns and doing a few more calculations.